Radix heap is a specialized implementation of priority queues for the shortest path problem. A useful property of Dijkstra's algorithm. The algorithm labels node in order of increasing distance from the origin. The bucket implementation. Finding the first node in a bucket takes O of 1 time. If the buckets have width 1, then each node has minimum label. If the bucket have width greater than 1, then we need to find the node in the bucket with minimum of distance, that is d of j. Finding the node in the bucket with minimum of d of j can take O of n time if there are a fraction of n nodes in the bucket. Now to the next slide. Bucket size grows exponentially. Ranges change dynamically. Here in this figure we can see that there are 6 nodes. The distance between the first node and the second node is 13. Third and fifth is 9. Fourth and sixth is 2. We can see different buckets with their ranges. Let the number of buckets be k. The initial width of the buckets are 1, 1, 2, 4, 8 and so on till 2 raised to k minus 2. Now let's move to an example. In the figure, first initialize the distance label, then initialize bucket and the ranges. Insert node into the bucket. Here the second, third, fourth, fifth and sixth node are in the infinity bucket. As we have not selected any node for the start, the distance will be infinity. Now select the node with minimum distance label, that is 1 here, as its distance is 0 here. Now scan the node 1 and update the distance label for the other connected nodes. So we can see here from the first and second node, the distance is updated. The 13 is written instead of infinity, and the node second will be kept in the bucket ranging of 8 to 15. Similarly with the third, the distance will be updated instead of infinity. As its distance is 0 from 1 to third, the third node will be kept in the 0th bucket and removed from the infinity bucket. Similar with the fourth, 15th is written and it will be kept in the 8 to 15th bucket. Similar with fifth, it will be kept in the bucket ranging from 16 to 31. The sixth node will be kept as it is, as we cannot directly go from first node to the sixth node. Here the work of the first node is completed, so we have marked it red. Now moving to the next node, we have to select the node which is having the minimum distance level. That is, the distance between the first node and the third node is 0, so it is minimum. So we have to take the third node. Now scan the third node and update the connected nodes. Now taking the fifth node, the distance will be updated. As you can see, the distance between the third node and the fifth node is 9, which is way smaller than the distance between the first node and the fifth node. So the distance will be updated at the fifth node, and the fifth node will be taken in the bucket ranging from 8 to 15. See, you can see here the distance is updated. So here the work of the third node is completed now. So we can move on to the next node. That is, first we have to find the non-empty bucket by scanning all the buckets from left to right. We can see here the first bucket is empty, second also, third empty, fourth is also empty. But in the fifth bucket, it is non-empty. So we have to determine the minimum distance value in the bucket by scanning all the nodes in the bucket. And we can see the node 5 is having the minimum distance, that is 9. So we have to redistribute the range of the bucket 5 into the first 4 buckets starting with value 9. Buckets which will stay the same except some may be smaller. So this is the updated one. Now we have to reinsert the nodes in the correct bucket according to the range. So we have to scan the bucket from left. So 2 will be moved to the fourth bucket ranging from 13 to 15. 4 will be moved from the bucket and it will be moved to the bucket ranging from 13 to 15. And fifth will be in the ninth bucket, range 9 bucket. At this point the leftmost bucket is non-empty. So select a node in the leftmost bucket, that is 5. Scan the node 5 and update the distance of the connected node. So now from the node 5 to 6 the distance is 8. So the total distance will be 17 and it will be updated at the node 6. Now we have to reinsert the node in the correct bucket by scanning from left. 6th node is removed from the infinity bucket and kept in the bucket ranging from 16 to 31. The work of the 5th node is completed. Now we have to find the minimum non-empty bucket. So first one is empty, second one is empty, third one is empty, but the fourth one is non-empty. And we have to find the minimum distance label in the bucket. So the work of the 5th node is completed. Now we have to redistribute the bucket according to the ranges with the minimum bucket. So these are the updated ranges. Now we have to reinsert the nodes in the correct bucket. So second, node 2 will be kept in the 0th bucket. Node 4 will be kept in the second bucket. Now we have to select a node from the leftmost bucket, that is 2. Now scan the node 2 and update the distance connected to the nodes. So the distance of the 4th node is updated and now the work of the node 2 is completed. So find the minimum non-empty bucket from left to right. So you can see 0th bucket is empty, first bucket is empty, but the second bucket is non-empty. If the bucket has a width of 1, select any node in the bucket. Now scan the fourth node and update the distance to the connected nodes. So the distance of the 6th node is updated and the work of the 4th node is completed. Now find the minimum non-empty bucket from left to right. 0th bucket is empty, first bucket is empty, second bucket is empty, third bucket is empty, fourth bucket is empty, but the 5th bucket is non-empty, having node 6. If the bucket has a single node, then select the node. Now the work of the 6th node is also completed. There are no arcs to be updated. So there are no nodes that need to be permanently labeled and the distance are already updated. Radix, a bucket based method for the shortest path. Buckets may be redistributed. Simple implementation leads to a very good running time. This was the summary for the Radix. Thank you.
If you really like this video, then please subscribe our channel and like this video. It takes only 1 or 2 seconds for you, but it is very important for us. So now let's end up this video here and thank you.